Good morning, students. Now I am going to start the class. Okay, and you listen very carefully. And in the last class, we discussed about the work, energy, and power. That topic I am going to continue now. Can anyone write the formula for the work, kinetic energy, potential energy? Start the class. Okay, and you listen. Okay, now I am starting the class. You listen very carefully. If you have any query while teaching, you write in the chat box. And today I'm going to close the work energy power chapter. In the last class, we discussed about the work, potential energy, and kinetic energy. Today I am going to explain the law of conservation of energy. What is law of conservation of energy? Okay, you listen very carefully. Our topic is law of conservation of energy. What is law of conservation of energy? Conservation means remains constant. Conservation of energy means energy remains constant. That I am going to explain now. When energy will be remains constant, what is the condition for that? That I am going to explain. You listen very carefully. If you have any query while teaching, you write in the chat box. Okay, right. What is law of conservation of energy? Okay, my voice and picture clear na? Writing. If you have any doubt, you can write. Okay, law of conservation of energy means conservation of energy. Energy conserved. Energy conserved means energy is remains constant. Energy remains constant means whatever the total energy it is there, that will be remains constant. Okay, right. That means energy can neither be created nor be destroyed, but it can be changed from one form to another form. That is the law of conservation of energy. Okay, energy we cannot create newly. Okay, and we cannot destroy the energy also, but we can do one thing, that energy can change from one form to another form. It's a statement I am going to write. You listen very carefully. That is, energy can neither be created nor be destroyed. We cannot create the energy, we cannot destroy the energy. But what we can do? But we can change energy from one form to another form. I will give the examples also. That means we cannot create the energy, we cannot destroy the energy. If you create the energy, the total energy will be increases. If you destroy the energy, the total energy will be decreases. Creating means generating newly. When you generate newly, then energy can increases. When you destroy, then energy can decreases. But we cannot create, we cannot destroy. That means energy cannot increase and cannot decrease. Energy always remains constant. Okay, the conservation of energy means That means the total energy in the universe is remains constant. Total energy in the universe is remains constant. This is called as law of conservation of energy. Law of conservation of energy is that the total energy is remains constant. Okay, constant means not changes, remains the same. This is called as law of conservation of energy. Okay, for example, I will give some examples at here. Okay, you are generating the electrical energy, right? For example, you have a electric generator. Electric generator, what it will do, it will convert the mechanical energy. Mechanical energy means kinetic energy. Okay, kinetic energy or the potential energy. It will convert the mechanical energy into electrical energy. Do you know hydel power stations? At hydel power stations, electrical energy, water falls from certain height. Due to that, the kinetic energy of the flow of water transferred to the uh, some shaft. With that, some device is there. It will convert the kinetic energy of that turbines into electrical energy. Like this, mechanical energy convert into electrical energy. For example, if you go for another example, that is electric motor, what it will do. For example, we have a motor. That means, what is electric motor? What it will do? Okay, the fan has the motor. Okay, the bore motor has water motor has pump motor has electric motor. Okay, what it will do? Okay, it will convert every car or any vehicle has the motor. Okay, engine it has this electrical motor. What it will do, it will convert the electrical energy. We have to supply the electrical energy, that is converted into mechanical energy, means it will rotate. Rotating energy is called as a mechanical energy. Kinetic or the potential energy is called as a mechanical energy. You go for the bulb. Okay, for example, bulb, what it will do, electric bulb, you see that electric bulb, what it will do, we supply the electrical energy for that. That electrical energy converted into the light and heat energy, right? Light and heat energy. Like this, energy can transform from one form to another form, but we cannot create the newly energy. This is called as the law of conservation of energy. Now, for example, if you, I'm going to erase this. If you want, you take the screenshot. Okay, right. Mechanical energy is what? What is a mechanical energy? Mechanical energy means mechanical energy. What is mechanical energy? Is it clear, students? Writing clearly appearing? Na? Yes. Do you have any query? Write in the chat box. If you have any doubt, write in the chat box. If you joined just now, then you do one thing. You write your roll number and section to note the attendance. Okay? Right. Now, what is a mechanical energy? Mechanical energy means the kinetic energy and potential energy are called as the mechanical energy. Okay? Kinetic and potential energy. Kinetic energy and potential energy. Okay, these are called as mechanical energy. Okay, mechanical energy. For example, if object is any object is thrown upward. Okay, consider one object is thrown upward. In case of vertically upward projected body. Okay, in case of vertically upward projected body. In case of vertically upward projected body, what happens while moving upward. For example, this is the ground. Okay, from here we thrown one object in vertically upward direction with certain velocity u. If you throw upward, while going upward, whether its speed velocity decreases or increases. Can you write the formula for the kinetic energy? The kinetic energy formula is half mv square. M is the mass of the body, v is the velocity of the body. And potential energy formula is mgh. Every moving body has kinetic energy. Any body, if it moves, we derived the kinetic energy formula and potential energy formula in the previous topic. If you want, you can refer. It is also available in the YouTube, my YouTube channel. Okay. Kinetic energy means every moving body. For example, the car is moving, bus is moving. That moving body has the kinetic energy. That formula is half mv square. For example, kinetic energy of the car, if you want, kinetic energy of any block you want, then m is the mass of body, v is the velocity of the body. Potential energy is the kinetic energy means energy possessed by a body due to its motion. Okay, potential energy means due to position. So due to if any object is at certain position from the ground, if any object is at certain height from the ground, due to the height, okay, due to the position and due to the compressed state, for example, rubber is stretched. Due to stretching of the stretched rubber, okay, compressed spring, elongated spring, that all have the energy. That energy is called as the potential energy. Potential energy means energy possessed by a body, energy have by a body due to the position or due to the state. This is the mgh is the potential energy formula. For example, if object is thrown upward, then it goes to certain height, right? It's while going upward, its height is increases. While going upward, height is increases. What about its velocity? Whether it decreases or increases? Write in the chat box, students. When an object is thrown upward, whether its velocity increases or decreases. While going upward, its velocity decreases. And after reaching the certain height, its velocity becomes zero. Further, it never goes upward. From this position, it will come back. That means the final velocity at this location it will become 0, right? That means the kinetic energy will become 0. While going upward, its velocity decrease at certain height, its velocity become 0. From this location where the velocity is 0, this is the highest point, highest position, right? At highest position, velocity become 0 and velocity becomes 0 means automatically kinetic energy is 0 and potential energy what happens, it reaches the maximum height at here, right? Height become maximum means potential energy maximum. In case of vertically upward projected body, what happens while going upward? The kinetic energy decreases. Why the kinetic energy is decreasing? Kinetic energy decreases due to decrease in velocity. Why kinetic energy is decreasing? Kinetic energy decreases due to decrease in velocity. But the potential energy, what happens? Potential energy of body. Potential energy of body increases. Potential energy of body increases. Why potential energy is increasing? While going upward, the height increases. Is it right? For example, if object is at here, the height is this much from the ground, we can measure the height. This is the height. An object goes to here, the height is increasing. That means when an object goes upward, while going upward, the height is increases due to the potential energy increases. Potential energy increases due to increase in height. Okay, due to increase in height. But here what happening? Kinetic energy is decreasing and potential energy is increasing. That means kinetic energy converts into that means kinetic energy while going upward in case of vertically upward projected body, kinetic energy converts into potential energy. Kinetic energy is decreasing, potential energy is increasing. That means kinetic energy converts into potential energy. Okay. पेपर है क्या? Now In case of what dropped body, what happens? In this case, kinetic energy, sum of kinetic energy and potential energy is remains constant. Sum of kinetic energy and potential energy is remains constant. Kinetic energy is mgh, potential energy is half mv square. Their sum is remains constant. This is law of conservation of energy. In case of vertically upward projected body, sum of the two energies will be remains constant. The total energy is remains constant. This is about law of conservation of energy, and that is in case of freely falling. Oh, sorry, in case of vertically upward projected body. Okay. Now, next one is the in case of dropped body. For example, if any object is dropped from certain height, you take the screenshot. I am going to erase this. In case of dropped body, what happens? In case of freely falling body, in case of freely falling body, what happens to kinetic energy and potential energy? Okay. If object is freely falling means this is certain object, it is falling from certain height. Okay, and this is the ground. The object is falling from certain height h. Okay, object is falling from h height. Now, while falling down, while going down, what happens? Its height will be decreases. Height will be decreases. When it is fall on the ground, from the ground its height will become zero. Right? The when it fall on the ground, its height becomes zero. That means while falling down, okay, whenever it is at this location, its height is more. When it come to here, the height is decreases. And when it fall on the ground, when it strike the ground, at that moment height becomes zero. That means while falling down, the height is decreases. But the starting you dropped it here. That means initial velocity zero at here. Initially you are not giving any velocity at here. Initial velocity is zero, right? But while falling down, its velocity is increasing because it is going fastly because of earth attraction force. Its velocity increases while falling down. Okay, that means in case of freely falling body, what happens? Okay, potential energy decreases. Potential energy of body decreases. Why potential energy decreases? Potential energy of body decreases due to due to decrease in height. Due to decrease in height. Okay, due to decrease in height. Why potential energy is decreasing? Actually, potential energy formula is what? Potential energy formula is mgh. That means potential energy proportional to h. If height is decreasing, then potential energy is decreases. H is the height. When height decreases, then height of object from the ground decreases, potential energy is decreases. That is in case of freely falling body, potential energy decreases due to decrease in height. But while falling down, its speed is increases. It strikes the ground with some high speed. Okay, right. After striking, it will come to rest. That means while falling down, its speed is increases. But that means kinetic energy depends upon the speed. The kinetic energy of body, freely falling body, increases. Okay, potential energy is decreasing. The kinetic energy is increasing. Kinetic energy of body increases due to due to increase in velocity. Due to increase in velocity. Now, the kinetic energy formula is half mv square. Okay. Here, the kinetic energy directly proportional to the square of velocity. When velocity increases, the kinetic energy also increases. Here, what happening in case of freely falling body? Potential energy is decreasing, kinetic energy is increasing. That means potential energy is converting into, in case of freely falling body, potential energy converting into kinetic energy. Okay, right? Is it clear, students? Do you have any query? Is it clear, students? Do you have any doubt now? At present, if you have any doubt, you write in the chat box. Okay? Right. In case of freely falling body, in case of freely falling body, potential energy decreases. Potential energy decreases. Why potential energy is decreasing? Potential energy decreases because of decrease in height. Okay, and kinetic energy increases. That means potential energy converts into kinetic energy. In this case also, the sum total energy, that is the sum of potential energy and kinetic energy, is remains constant. That is the potential energy plus kinetic energy is equal to remains constant, either in case of freely falling body or in case of upward projected body. In dono cases, in two cases, the sum of the potential energy and kinetic energy is remains constant. Okay, right. This is about law of conservation of energy. The next topic is power. What is a power? When we say that a person has more power, okay, you take the screenshot and note it. I'm going to erase. Next topic is the power. Okay, who has more power? What is the definition of the power? Okay, if anyone, if any person doing the, if any person, okay, doing more work, then that person is said to be have more power, right? For example, if the two persons are doing the same work, but one person is doing the work in the less time and other person is doing the work in the more time. For example, uh, we are carrying the some 10 bricks to first floor. Okay. First person carries the 10 bricks to first floor in 5 seconds. Second person carries the same 10 bricks to the first floor from the ground floor, okay, in 10 seconds. First person carries the, okay, 10 bricks, 10 bricks, okay, from ground floor to first floor in 5 seconds. Second person carries the same 10 bricks from ground floor to first floor in 10 seconds. That means the both persons are doing the same work. They are carrying the 10 bricks to first floor. Same work they are doing. But the thing is that the first person completes the work in the less time, 5 seconds only. The second person completes the same work in the 10 seconds. Out of these two persons, which person has more power? That is my question. Can you tell? Write in the chat box. In the normal mode, you tell which person has more power out of these two persons. Whether first person or the second person. The person who complete the work in the less time, he said that we say that he has the more power, right? Very good, Aditya Chauhan. First person, we say that he has more power, right? Because he completes the work in the less time. Okay, that means Abhishek Kumar also gave the answer first person, right? Good. And now the power means the rate of doing work. The power definition is rate of rate of doing work. The rate of doing work is called as the rate of doing work is called as power. The rate means what? Rate means a time rate. If any work is divided with the time, then we say that the rate of doing work is called as power. Okay, rate means what? Work should be divided with time. Then we say that the rate of doing work. The power is depends upon two factors. Okay, power proportional to work and the power inversely proportional to time. If any person is completes the work in the less time, time is less means power is more. Work more means power more. Directly proportional means one is more means other is more. Okay. And work is less means power is less. Time less means power more. Power less. Okay. And from this we write the power is equal to work by time. If you combine them, power formula is work by time. Okay. And this is the formula for the power. Power is equal to work by time. So the power denoted with P, we write as P is equal to W by T. P is equal to W by T. This is the power formula is work by time. Now I want the power unit. What is the SI unit of the power? SI unit of power. Okay. From figure also, from formula also we say the power unit as power unit is watt. WATT. Okay. Power is the unit is watt. WATT. It is the unit of the power. Simply capital W we write. That is nothing but watt. WATT. Or simply based on the formula also we write work unit is joule by time unit is second. Joule per second also we can write. Okay. This is SI unit. And other unit I want some other unit also there. There are many units are there. Okay. Other units. That is other units are the horsepower. Horsepower is also unit of the power, that is HP. 1 HP motor, bore motor will be there, water motors, 1 HP motor, 2 HP motors like this. 1 HP equal to how many watts? 746 watts. Okay. 1 horsepower means 746 watts. And some other units also there, that is kilowatt. Kilowatt. Okay. Kilowatt, 1 kilowatt means 10 to the power of 3 watts. Megawatt power. Electric power we can measure it in the megawatts. Megawatt means 10 power 6 watt like this. Okay. And now these are the other units. How to define the power? Power definition is the rate of doing work. Work done per unit time is called as the power. Work by time is called as the power. Its unit is work unit is joule by time unit is second. Joule per second is the unit for the power. Okay. Right. And for example, I'm going to erase this. You take the screenshot. How to define the 1 watt? I want the definition of 1 watt. How to define 1 watt? How to define 1 watt? What is what? Watt is the unit of the power. Okay. Power formula is what? Power formula is work by time. Right? Power formula is work by time. Okay. Power we write, power we take as 1 watt. Okay. Work we take as 1 joule. Time you take as 1 second. Okay. Then we write as 1 is equal to left side 1 is there, right side also 1 is there. 1 watt equal to we write as 1 joule by 1 second. Or otherwise you can take the work as 1 joule. Okay. And the time is 1 second. By taking these values, you find the power from above formula. If you find out the power, work you write 1 joule. By time you write 1 second. Then we get as 1 joule by second. Joule by second is nothing but watt. That means if any person do the 1 joule work in 1 second, his power we say that 1 watt. Right? The definition we write like this. Definition of 1 watt. Definition of 1 watt we write like this. If 1 joule work is done in 1 second, okay. If 1 joule work is done in 1 second, if 1 joule work is done in 1 second, if 1 joule work is done in 1 second, then then the power is equal to 1 watt. Then the power is equal to 1 volt. Understood? Right. Do you have any query? Write in the chat box. Is it clear till now, students? Do you have any doubt? Write in the chat box. Next one is some note point I am going to give that are useful to solve some problems at here. For example, we want to lift some object. Power, okay, power of a person, power to lift m mass of body to h height in time t. We want to lift one body to h height. Okay, if you want to lift any object to h height in time t, its object mass is m. Then how much power you have to use? Power formula is what? Work by time. But how much work we are doing it here? We are lifting the object. We are applying the force at here. That work done to lift the object is equal to potential energy at here. Work is equal to force into displacement. Okay. And this force we rate is equal to gravity, weight, mg. Displacement is h. Rate is power equal to mg h by time. Okay, mg h by t. Next, I am going to erase this. Next one is the power required, power of a gun which release a bullet of mass m with velocity v. Okay, I want to find out the power of a gun, okay, which release a bullet of mass m with velocity v in time small t. Then the power formula is again work by time. Which work we are doing it here? We are sending the bullet. Okay, bullet gives the kinetic energy to the, sorry, gun is doing the work at here. Okay, the gun is giving the kinetic energy to the bullet. It means here power of the gun equal to work done by the gun by the time. Work done by the gun is equal to kinetic energy of the bullet. Kinetic energy of the bullet is half mv square by time is t. This is the power of gun which releases a bullet with of mass small m with velocity v. Next one is power formula. Okay, power required to move a object with velocity v under the force F. We are applying the force F on object. Then that object is moving with velocity. How much power required? Power formula is, we know, work by time. Work formula we write as F bar. Sorry. Work formula is what? Fs, force into displacement by time. We write as the force into displacement by time. We write as displacement by time formula is what? Displacement by time is nothing but velocity s by t. Force into we write as velocity. Power, another formula is force into velocity. Force into velocity. Right? Clear, students? Okay. Now, next one is the commercial, last topic. Okay. In this chapter, there are three lectures are there in this chapter. Okay. Last one is the commercial unit of power, commercial unit of energy, commercial unit of energy. What is the commercial unit of energy? Kilowatt hour. Kilowatt hour is nothing but kWh. kWh. Okay. Kilowatt hour. kWh. Kilowatt hour is the commercial unit. Commercial unit of electrical energy. Okay. Electrical energy. It is the unit of the energy. Energy unit joule, you know. What is this? Kilowatt hour, how it will be energy? We know, we know power formula, right? What is the power formula? Power formula is work by time. From this work formula, what we write? Power into time we write. Work is equal to power into time. Okay, right. Work is equal to power into time. What is power at here? Kilowatt. Power unit we write is work is equal to energy, right? Here work is equal to energy we write. Because work done will store in the form of energy. Energy is equal to, we can also write as power into time, right? Power into time. Because power equal to work by time, work is equal to power into time, work only energy, means energy is also equal to power into time. Means energy unit is, energy formula is power into time. Means power unit we write as kilowatt also, kilowatt. Time unit hour also we write. Kilowatt into hour, power into time gives energy. Means from this we write as kilowatt hour. Then 1 kilowatt hour equal to how many joules? This kilowatt hour equal to how many joules? 1 kilo into 1 watt into 1 hour we write. Because 1 kilowatt hour means 1 into 1 into 1 we write. 1 kilo means 10 to the power of 3 we write. 1 watt means we write as 1 joule by 1 second. 1 hour means what we write? 1 hour is the 3600 seconds we write. This will cancel. Then we will get as 3600 into 10 to the power of 3 we write. This we write as 36 into 10 to the power of 5 we write. Joule. Okay. Then 1 kilowatt hour is equal to, we will get as 36 into 10 to the power of 5. This we can write as 3.6 into 10 to the power of 6 joule also. This is 1 kilowatt hour equal to 3.6 into 10 to the power of 6 joules. Generally, electrical bill you will pay based on the number of units. For example, generally every month you will get the electrical bill from the electricity department. How you will get the electric bill? Okay, for example, in one day, if you consume, in one day, if you consume, sorry, in actually the electrical bill is based on the number of units. Number of units. Okay. For example, there is a meter reading is there. There is electric meter will be there. In that electric meter, initial reading, for example, initial reading is initial electric meter giving the initial reading as 231. After 1 month, it is giving the reading as 261. Okay, or 291. Like this, it will give 231 initial reading. After 1 month, it will be giving the 291. Means 291 minus 231 you will do. Then 0, 6, 60 units you will get. 60 units means government will decides that 1 unit 2 rupees like this, 2 or 3 rupees. Then 60 units means 60 into 2, 120 rupees bill you will get. Okay, once again I will explain. Meter, you in every house, in every home, there is a meter, electric meter. In the digital meter, there is a initial reading will be there 231. Okay, and after 1 month it is showing the 291. They are using the electrical energy, that's why the reading is increasing. Then final reading minus initial reading you will do, you will get the sum, how many units you consumed. 291 minus 231, 60 units you consumed. So this is approximate example only. 1 unit cost will be 2 rupees. 60 units cost is 60 into 2, 120 rupees. You will get the 120 rupees bill in the for the electricity board. Okay, and like this they will calculate. Then 1 unit energy, 1 unit we are consuming means how much energy you should consume. Okay, electricity department is telling that for 1 unit 2 rupees you are paying. 1 unit means how much energy you will consume. That is electrical energy can be measured in units. That electrical energy is equal to 1 unit. 1 unit indicates 1 unit means 1 kilowatt hour. Okay, 1 unit means 1 kilowatt hour. If you will use 1 kilowatt hour energy, 1 kilowatt hour is the energy only, na? If you will use 1 kilowatt hour energy, then we say that we consumed the 1 unit. That means 1 unit equal to 1 kilowatt hour energy you are consuming. Okay, right. This is today's lecture, and remaining we will discuss in the next class. In the next class, we will discuss few problems based on the work, energy, and power. There are three lectures are there based on this chapter. In three lectures, total concept is covered. Once again, you can watch all the lectures and revise it. Okay. Thank you to all. And if you not wrote the roll number for the attendance, kindly write the roll numbers. Okay, and then leave it. Leave the class. If you have any query, you write in the chat box. If any doubt, write in the chat box.